California for a couple of events down there. And now I'm up in Seattle. I'm working on, like Siegel said, I'm working on mushrooms of Pacific Northwest book similar to mushrooms of Redwood Coast, with a fairly quick turnaround. So hopefully that's going to be out in September of 23. And I don't think about coming east. I mean, it's something I should do because I did, you know, I technically am still an asshole. Massachusetts is my home. You know, that's where I grew up and still live. But you know, at least before COVID, I was away from home more than I was home. And with things opening back up again, that's probably going to be the case. So I'm going to talk to you about a group of fungi that don't necessarily get a whole lot of, I guess, a whole lot of people looking at them. Partly because it's a difficult group, and so this is Bankeraceae, which are the group of like the tough woody tooth fungi. So that you know, Sarcodon, Hydnellum, Phelodon, Bankera, at least in the old sense. We'll talk about the new sense. And then one of the polypore-like things, a Bolitopsis, which you know, which looks sort of like an albatrellus until you look at the spores. It's a group of fungi that, if you're after edibles, you're going to be really disappointed with this group. Better than like the hawkswing, you know, on the Sarcodon, I don't think any of them are eaten. I know that people eat a lot of things I wouldn't necessarily eat, but for the most part, most of these things are going to be too tough or you know, just really fibrous, so you wouldn't necessarily eat them. There's some really pretty ones, you know, like Hydnellum pecci with the red droplets coming out of it. Of course, 90% of the time you see this fungus, it doesn't look like that. But there's tricks that you can make to look like that. I'll tell you about those later. And then there's a lot of like drab, earthy brown colors with this group as well, especially with the, you know, what we knew as Sarcodon. You know, there's just not a lot of brightly colored species. So, make sure this is working and we have advanced slides. Give me a thumbs up if this is showing up right. Okay. So just you know, the general, what, you know, what are they, where do they belong? So in you know, in order to Leporales in the family Bankeraceae, like I mentioned, that you know, there's 5 genera in Bankeraceae. A couple of them, so Phelodon and Bankera. Bankera has now been synonymized with Phelodon, if you want to believe that. It depends on how much you want to use macromorphological characters versus DNA. You can have that discussion as much as you want, especially with Quaternaris being split up now. And then a lot of the Sarcodons, what we knew as Sarcodons, were moved into Hydnellum. So there's only a few things left in Sarcodon. Most of the former Sarcodons are in Hydnellum, except for the Atrobarides group, which that small group of Sarcodon needs a new genus, and so someone's going to have to describe a genus for that. And there's, you know, there's a couple species in North America, a handful in South America, at least one in New Zealand. So not a whole lot of them. But you know, within the group, not too many things there. They have white to brown spores, so Phelodon and Bankera have white spores. Everything else in this group has brown spores, kind of like, you know, these earthy browns. Not that you have to do spore prints on these things. I don't think I've ever done a spore print, intentionally done a spore print on a tooth fungus. Of course, you let them sit around for a day or two, you're going to get spore prints from them usually. And it's really easy to see the spore print for this group of fungi in the field, just because they're out there for a really long time, and they produce a lot of spores and they just stick to the leaves underneath them. But if you're just getting started, you need to, you know, be able to tell a Phelodon from Hydnellum, then you could do a spore print off of them. But the spores themselves are fairly small. A lot of Hydnellum spores are about 4 to 5 microns, globose, subglobose, but they've got, you know, all these little like projections, little knobs coming out of them. They're not, you know, they're not a round spore. It's, you know, these trabeculate spores, all these little bumps and knobs coming out of them. Sarcodons, for the most part, have larger spores. So a lot of the sarcodons that are still in sarcodon have spores about over 7 microns long, I believe. So we won't spend too much time on microcharacters because for the most part, they're not all that helpful. There's a couple groups that you can tell apart by spore size, but we'll get more into that later. So other stuff in Telephoraceae, you know, Telephoraceae with Telephora, of course, Tomentella, the ECM crust fungus, and the Polyozellis. So that's another group in this family. And of course, the mushroom dyers know this because they all produce the same blues and green dyes with the, you know, with the pH modification. They all have the similar pigment to them and similar spores to them. So, you know, a lot of these things have these kind of like weird bumpy spores that, you know, the whole family does. And it, you know, it's like, if you want to see what clamp connections are supposed to look like, you can look at, you know, anything in, pretty much anything in Telephoraceae, you know, Tomentella especially, you'll just have really clear examples of it. So it's a, you know, it's a really interesting group to throw into the scope, but like I said, we're not going to spend too much time on that. We're also not going to get into Bolitopsis and the mess of Bolitopsis right now. There's a handful of species using the same names, but remember that this is, Bolitopsis is in Bankeraceae. So it's a tooth fungus that has pores. You know, it looks similar to Albatrellis, those, you know, those fleshy stalk polypores. And in you know, just looking at it macroscopically, there's a couple that, you know, they'd be a little bit difficult to tell apart, or Bolitopsis from Albatrellis, but for the most part, it's fairly they're fairly straightforward to identify as a genus. Probably going to end up being 5 or 6 different species of Bolitopsis when the dust settles in North America. So not that bad, but you know, we pretty much call everything now Griseus if it's gray, and what's it, Leucomolania if it's black and with spruce. But there's more to that story. And then for the other groups of spiny fungi, I'll just use this as an example. So here's a bunch of different animals with spines. Of course, you know, New World porcupines from North America, first the Old World porcupines from Africa, hedgehogs, tenrecs, and echidnas. So what do all of these have in common? They all have spines, right? So what do all these tooth fungi have in common? Well, they have spines, but when you start looking at them closer with animals, there's a lot of different things, you know, different rodents in between New World and Old World porcupines. So they're not all that closely related to each other. The hedgehog's closest living relative is a shrew. The tenrex is an elephant. Don't ask. And then the echidna's closest living relative is the platypus. So, you know, these monoterms that lay eggs, you know, Australia, everything's weird there. So when you look at fungi, the same thing has happened. So there's convergent evolution going on where you have all these different fungi that have, you know, developed spines. So of course, the one that most people know, the hedgehog mushroom, the hydnums, which are you know, kind of those warm orange tones, brittle flesh, they break apart really easily, but the, you know, the underside is all spiny. The jelly tooth, the pseudohydnum, of course, hydnellums, this little Bickinia, which is a New Zealand thing, and then Oroscalpium, the little pinecone tooth, well, it's pinecone back east, Douglas fir out west. And they, you know, they have those same tough fruit bodies, the spines and underside of the cap. But when you look at them closer, you realize that, you know, hedgehog mushrooms are really closely related to chanterelles. And the jelly tooth is a jelly fungus. Like I mentioned before, the hidnellums are in Bankeraceae. That little thing from New Zealand's closely related to like Romeria, kind of in that gomphoid phalloid clade of stuff. And Oroscalpium is closest related to Arustula. And of course, with polypores, spines have evolved, I think, at least 7 different times within the group. So at least 7 lineages of polypores have developed those spiny-like structures on the underside of the cap. And so all of these things, there's differences to the group of tooth fungi I'm going to be talking about. Sometimes polypores, some of these polypores can look similar, but the ones with the central stem anyway, or the off-center stem, the stiphotype polypores with spines are all like quite obviously growing on wood in Eastern North America. Anyway, you go elsewhere, that changes, but we're gonna stay in Eastern North America for this talk and pretend the rest of the world doesn't exist. And like I mentioned, that the hedgehog mushrooms, or sweet tooth, whatever you choose to call it, that these are, they're spiny mushrooms, but they're really brittle. They break apart really easily, and they're pale, warm-colored mushrooms. So white to peach colored to orange typically. They typically stain orange. So with that combination of colors, you can pretty much tell them apart from the rest of the tooth fungi. And Sigrid, I don't know if people are aware that they're drawing on the screen or not.
I'm sure I'm not aware. So please, whatever you're doing, do not drag your cursor across the screen, because it actually can show up. It's a weird bug on Zoom, and it's it's not desirable, and there's nothing I can do about it. So please just don't do it. Okay.
If you're aware you've done it, there's an undo feature for it, but a few green lines isn't going to bother me too much. So the hidnums are fairly closely related to chanterelles, kind of like sister groups to each other. And if you can look past the gross, macromorphology features to them, look past the fact that one has ridges and one has teeth, you'll see a lot of features that tie in, especially micro features. So you have to just be aware of convergent evolution of fungi happening again and again and again, and not get too hung up on what the actual fruit body looks like. Micro characters are a lot more conserved, and they don't change as much. So the spores are usually enough to tell you that you have something in Bankeraceae. So we really should be calling these things spiny chanterelles. Why not? Give it a try. So moving into the group that I am going to talk about, I'm just moving a couple things here on my Zoom. All these things covering up my screen. So hidnellum in the classic sense. So I touched on a little bit earlier. Hidnellums have been lumped. So we're talking about lots of like splitting going on, with a lot of sarcodons were moved into hidnellum. So there's a lot fewer sarcodons now, a lot more hidnellum. So on a generic level, there's fewer genera in Bankeraceae because we've gotten rid of Bankera. So they're all in Phelodon, and most sarcodons have moved into hidnellum. So we used to split them based on the indeterminate growth of hidnellum versus sarcodon, which was kind of determinate growth. And so what is indeterminate growth? It's when the mushroom comes up and it starts growing and it stops, and then it grows again and it stops and it grows again, and it can kind of like engulf organic matter. So you just think of like the sticks coming up, those little plants growing there, and the mushroom just kind of like grows around it and completely engulfs that stem inside the fruit body. Compared to these mushrooms that their growth is predetermined. It's gonna it's like the amanita egg. Everything's made before it even comes up. It just comes up and grows. That's its fruit body. With the hidnellums, they can just go up and can keep adding upon themselves and growing and growing and growing for as long as the fruit, the year is. And so in the Northeast, typically I'll start in midsummer and go into mid-fall, late fall. But if you're like on the Pacific Northwest coast, some of these fruit products can last over a year, and it just keeps adding upon itself, and they become these massive, misshapen, weird growths with like fresh caps coming up out of that. So we used to split them by the indeterminate growth and the tough fibrous flesh, but we can't do that anymore. So when you're IDing these things, what you need to look for is flesh color. Without cutting the mushroom in half, it's really difficult to identify them. Odor and taste is pretty important with this group. There's not a lot of variation, but there's a bunch of species that are like, Hidnellum peckii, the bleeding tooth, when it's completely brown and has no features that you would necessarily recognize left to it, you can still ID it from a quick taste, because a quick taste of that mushroom will, immediately, it's like battery acid almost. Not that I've eaten battery acid, but it will literally make your mouth burn from just like touching your tongue to it. The cap texture. So that's you want to look at the cap in a mushroom and see, is it smooth? Is it hairy? Is it roughened or bumpy? Does it have like all this stuff, these little growths coming out of it? Like this one, you can see all these little pilei coming up out of the top of that cap. Does it have that feature or not? And then the habitat. And with the habitat, mostly just hardwood forest versus conifer forest. So is it a conifer associate or is it a hardwood associate? That's going to be helpful in distinguishing a handful of closely related species. And this is, the classic example of Hidnellum, and that, this is one that, most people know just from the photographs of them. The strawberries and cream, with the red droplets coming out of the cap. But you can see, here, like the spine color is not indicative of spore color on these things, especially when young. Don't get fooled by pale spines on a Hidnellum thinking it's white spored Bankera, Phelodon or Bankera, because the spine color can stay really pale on some of these Hidnellum. So Phelodon, the white spores. Before, once again, we split these out with the white spored, indeterminate growth, and tough and fibrous versus Bankera, which were the brittle fleshed, non-indeterminate growth. But with Phelodons, you want to be looking for pretty much the same features that we're talking about with Hidnellum. The flesh color, odor and taste, cap texture, but then the duplex of the stipe is important. When you cut it in half, is the outside layer a spongy layer and the inside core really hard? Does it have that or not? Because that'll be helpful feature to look for on the ones with the really spongy stems versus the ones that don't have that. And that's something to look for, because you can see the previous one, the Phelodon app Niger, this group here has a really spongy base, when the Melaleucas group, you can see, has a really thin fibrous stem with no plushness to it. And a lot of Phelodons are smaller and thinner flesh than Hidnellums. Not all of them, but a lot of them are. Okay, so Sarcodons, as we used to know them, were the fragile, brittle caps that would break easily. The stems would be a little bit tougher, but you could typically break them apart fairly easily. Many had that scaly cap to them. The cap just like breaking up into little scales. Some of them are smooth. Most Sarcodons have, what I describe as earthy colors, these brown tones, from light brown to dark brown, sometimes olivaceous brown. There's a few that are more colorful. There's a couple that are purple, not in the east. Well, there's one that's sort of purplish. There's a couple orange ones, but they're for the most part 50 shades of brown. Most sarcodons have a bitter taste to them. What you want to be looking for, one of the important features is a stem base a different color, and then the basal mycelium color can be important as well. And in the strict sense, what sarcodons are now are pretty much what you see on this screen: the Sarcodon imbricanus and squamulosus, these larger scaly cap ones with larger spores. So like the hawkswing, this is a true sarcodon. Most of the rest of pretty much, besides on squamulosis, everything else in the Northeast, which we have been calling a sarcodon, is probably in Hiddenellum. The genetics haven't been done on all of them, but it seems that most of them anyway are going to end up in Hiddenellum. Bankera, as we used to know it, where these more fragile mushrooms, white spores, it would have more of a smooth cap. It wouldn't get scaly like a sarcodon. The two species we have both have really sweet odors to them, and like slightly bitter taste, not like the the really bitterness of the sarcodons. You could pretty much tell them in the field, because if you pick them, you could see the spores on the duff, or on the ground underneath the cap. They produce a lot of spores, and so you flip them over, you can usually see the spores. Both of them have really short stems and are close to the ground. So this Bankera, or now Phelodon, Fuligineo alba, one of the 2 and 3 needle pine forests across North America. So when you're identifying Hiddenellums, I touch on these features that you want to look for. So here's an example of a mushroom. What do you need to notice? You need to notice, like I said, the cap texture. So you can see it's all fuzzy on this one. Pretty distinctive. There's only a few species that have a fuzzy cap like that. So you can really narrow it down because of that. The color change in the cap, young versus old, growing margin, the edge of the cap versus the center, especially when they get older, you'll see this drastic color change. And it makes Hiddenellums really hard to identify because of that indeterminate growth and that really long lifespan of the fruit body. They can go through drastic changes of what they look like, just wet versus dry. The spine color is important, and the tips of the spines are usually a different color than the upper portion of the spine. So when you cut them in half, you'll see in cross section that on these, it's just the tip is white, but when you look at it on the side, are brown. And sometimes when you flip them back and forth, you'll notice like a flash of color because of that. Flesh color, extremely important. On a lot of these groups, if people show me a picture of a Hiddenellum without flesh color, I won't even venture guesses on them. Just cutting it in half and showing that flesh color is really important for identification. Not as important, but neat are the little droplets on them. So a bunch of different species exude these little droplets. Hiddenellum peckii, super obvious, bright red droplets in the cap. Just because it has red droplets does not make it Hiddenellum peckii. And something I do is go on iNaturalist every month or so and rename about 100 observations of abortoporus, which also has red droplets. And then all these different Hiddenellums that form red droplets that just get called Hiddenellum peckii. In some cases it's important, in many cases it's not. With this particular species, the indication of these little orange brown droplets do help separate it from Hiddenellum cristatum, but the habitat separates it as well. So like I mentioned, notice hardwood versus conifer habitat. And probably the biggest thing is the age of specimens. They change so much. So when this thing is young and fresh, it's almost a white cap and a blue stem compared to what it looks like here. And you think I would have stuck that photo in there, but no, I screwed that one up. This is another example of that. So here's mushrooms from the exact same spot as this, taken about a week apart. So this is Hiddenellum aurantiacum, where it's been really wet. It rained really heavily on this group versus this group where it's gotten a chance to dry out a little bit. So it's taken about a week later from the same spot. So you can see how much these mushrooms have changed in appearance over a short amount of time. So it's going to be, you're going to have to look at everything within a range, saying, okay, if it's orange to deep orange brown or red brown, and it has white spines and red orange flesh, then it's probably this species. But it's going to be difficult sometimes to tell these things apart, depending the age you find them in. And I mentioned cap texture. Here's a couple examples of that, where you have kind of like this really finely fuzzy pubescent tomentose cap, where you run your finger across it, it's like soft, versus this one, which there's no hairs at all on it, but it's really roughened and bumpy. And so cap texture is pretty important feature to note on Hiddenellums when you're trying to ID them. And then spine color, especially spine color of young specimens, or at least the growing margin, something important to note. We call every orange Hiddenellum aurantiacum, but most of them we see in the Northeast are not. And so when you see the white spine color in the young versus the orange, that alone can tell you that these two are different species. If you want to put a name on them, we'll get into that later. And then I mentioned the flesh color, and I can't stress the importance of this enough. If you want to ID these things, you have to cut them in half and look at flesh color, because it is the only consistent color on a Hiddenellum, it seems. So when you cut them in half, they retain the color throughout the whole lifespan of the fruit body. Cap color can, especially on this species, Hiddenellum, when it's young, it's a beautiful blue color. But it quickly loses that blue colors, and as it gets older, we'll have no blue color left in the exterior of the fruit body, but it retains the blue in the cap flesh, and has an orange stem, which is unique. Well, not unique, but it's distinctive. And then I mentioned bleeding. It's really cool to see. At least with Hiddenellum peckii, like I said, it's not like this very often, but if you find Hiddenellum peckii that's kind of this like pinkish color without the droplets, and you want to see the droplets, just squeeze it. So this was something that I think Kate Mohat discovered when we're up in Alaska. We're seeing a lot of Hiddenellum peckii, and we picked a few of them, and then she just happened to squeeze it, and then all these red droplets like popped up, just like bubbled up out of the surface. And you let go of it, they go right back in. And you can literally like squeeze for droplets. I have a few videos of them, but I didn't throw them into this talk. But I think if you go on my Facebook page, I have a couple of videos of it up there where you just like squeeze these mushrooms, cover with the red droplets, release. They all soak right back in really quickly too. So if you want your strawberries with your cream, then just squeeze for it. So I'm going to run through a bunch of different species of Hiddenellums here. I mean, I don't know what to tell you in terms of like IDing them. It would be good if you can start to recognize at least the common species. And then also the ones that are really unusual, because the really unusual ones are the ones that I kind of need collections of. It's going to take a lot of work, a lot of collections to both describe variability and just to show diversity of them. A lot of these species, they're, at least in Europe, they're disappearing. They're probably disappearing in North America too. We just don't really notice stuff like that here. They are highly susceptible to acid rain. They seem to be, a lot of them, especially out west, seem to prefer mature or old growth forests. So you'll still see these things, but you'll see them in the small remaining pockets of old growth. They're not all that widespread. They're fairly specialized to a habitat or to an area. Another thing about Bankeraceae is they're communal fruiters. So you'll often find a patch where there's a lot of different species growing together. And so like there's a spot near my house in Massachusetts where I can go and I've seen 15 different species in the family in Bankeraceae at fruiting at once in a spot that's probably about 100 square feet. You know, just this little like mature, it probably, you know, with an old growth component, it was probably like just little rocky hill that probably was only selectively cut. One of the few spots in town that was never fully cleared. And so, you know, just within that area, there's a lot of these different species growing, and you can go around and see this, not just throughout North America, but the spots I've been in New Zealand and in Australia, which I have a lot of hidden elements and phelodons. The same thing happens there. You see one, you see multiple species in the same area. So it's a communal fruiter similar to what Phaeocolybia do, which is a Pacific Northwest, mostly PNW group of brown spot ECM fungi. And then other things like non-ectomycorrhizal stuff like Hygroceae and Leptonia and Pseudobaiospora, those will all grow together in the same habitat as well. So yeah, you find one hidden element, you can see a lot. That being said, you want to make sure that you are collecting the same species and not mixing collections. That can be hard sometimes, especially when they get older. So with hidden element Bankeraceae, this is what you'll normally see when it looks like. Even like this, it's easy to identify because of the color of it, kind of like that pinkish or whitish to pinkish growing margin, and with the dark brown to almost black center. And so the growing margin on it will retain those pink colors, but like I said, not always have the droplets. And also, if you were to taste this much and just bite your teeth into it or get any of the juice on your mouth, it's extremely acrid tasting, burns your mouth, so it's really strong. These are all different examples of different ages of hidden element Bankeraceae. And all of these examples are Western North America. This is Eastern North America. So in the East, it mostly grows with pitch pine or jack pine or spruce. Out West, it's mostly spruce, occasionally pine. It's not all that picky. There's multiple species going by that name. Not exactly sure which one was described first, if it was the pine associate from the East or the spruce associate from the East. It will matter because, like I said, there's a couple different species using that name, and there's a couple other options for names. But this is an example from Cape Cod, where it loves the pitch pine. You get down to the Pine Barrens in New Jersey, it can be similar down there, and continues with the long needle pines down in the Southeast. And so, fairly widespread. But usually when stuff is fairly widespread, it raises those alarm flags that it may be more than one thing here, but not so much within this family, because there's some really widespread species. Like hidden element mirabile, pretty much across northern temperate areas with conifers, same species. The Bankeraceae violescens. These things, some of them are really widespread, some aren't. The closest look-alike to in the same habitat, often growing side by side, is this hidden element Ferruginum. And so the difference to this is the growing margins are going to be whitish to tan, not necessarily pink. And then it doesn't have the acrid taste, and it doesn't get the droplet. So just it's going to taste earthy or slightly farinaceous. It's not going to burn your mouth at all. So even if it's a really old mushroom without the growing margin, you can still distinguish it just based on taste. You can kind of see, like when I talk about this indeterminate growth, you can see how this is just engulfing all the pine needles there. I cleaned these up a lot of the, to make that, show the fruit body better. If you just pluck that out of the ground, all these needles, coming up out of it, kind of like growing out of it. And something I didn't touch on before is, you can see on here that mycelial mat it's coming out of. A lot of these these hidden elms and phelodons form a really dense, rhizomorphic mat under the soil. And probably multi-species on these mats, like I mentioned, all them growing together, to probably, there's probably some sort of interchange of nutrients or something going on in those those mycelial mats underneath the soil. But most of these hidden elms form those rather dense mats. And so it's probably, if you're collecting these things, and if you are collecting it because you're a mushroom dyer, it's probably good practice not to disturb that mat too much. Don't pick them all, and maybe cut some of them off if you're plucking them out of there. Just another example of this this hidden elm, a little bit younger. Once again, you can see how it just engulfed that whole wintergreen plant in the fruit body. But with this one, easy to tell from Heckiae because of the lack of the acrid taste and more tan to light brown colors, not the pinkish color. But then there's this one in particular, which some people have synonymized with Ferruginium. It's not, it's a separate species. It grows in a slightly different habitat. You're going to find this one mostly in hemlock forests, or around me. You can't get hemlock without white pine typically. So you see all the pine needles in this picture, but it appears to be a hemlock associate. It gets the red droplets on the underside like Heckiae, but the cap is typically, it was at least when wet, like this puddle of red juice. So not, it'll be, just this pool of juice in the cap, not individual droplets. And then the growing margin will be a little bit more, on the cap color, a little bit more on the reddish side. So not, not more like Heckiae, and a little bit less like Ferruginium, but really similar, and it does not taste peppery. So something to look for. And another example of this, but you can see really similar to Heckiae, with that, the whitish to pinkish growing margin, even gets, the red droplets, but, one quick taste of this would separate it. And a few of these photos, I do have examples of yarn dyed with these mushrooms. A fairly common hidden elm around me, once again, mostly with hemlock, but probably I would imagine most of these species, these conifer species, are probably with the wide host of different conifers, and not all that picky. Just for, most of the time I'm hunting in hemlock forest. I don't get very much spruce around me, but it does appear that the hemlock stuff just jumped ahead to spruce and fir as you go further north. But that's this hidden elm cumulatum. This is one that for years I just called it the clustered stackers, because they're growing these fairly large clusters, and then the fruit pies are just like keep piling upon themselves. When it's young, it kind of has that the cumulus cloud, the puppy gray fibrils on the cap. But as it gets older, it loses those, and it just looks like any other brown hidden elm. But those young cap margins with that kind of like that downy pubescent grayish color, with the pinkish growing edge, or whitish to pinkish growing margin. And as you can see, a lot of these hidden elms stain brown when you touch them. So if it's something that you pick in the field and you handle it and bring it back, chances are your growing margin color is all going to be stained up unless you're careful with them. Just another example of this mushroom, it is quite variable. But when it typically has some of that grayish downiness to the cap margin, unless it's like this and it doesn't. And so just another example, these are all mushrooms that I could watch over a long period of time and kind of watch them go through their changes, because like I said, I mean, they're in there, they'll be growing for 2 or 3 months sometimes. When it first starts coming up, expanding, stopping and starting. If it's a dry period, it's just going to shut down, waiting for that next wet period and continue growing. So like I said, variable within a range, and so you gotta figure out that range. But then you can find other stuff like this that's variable, but outside the range. And so this is one that I have not been able to put a name on yet. It's probably undescribed. This is just a mixed forest around me, but there were some spruce, hemlock, oak, beech. We're moving to hardwood forests. We have Hidalum Spongiocepes, and this is probably the easiest one to identify, and at least south of New England, in the east, the most common one. Once you get up to my area, Massachusetts, I've never seen this much in there. It does occur eastern Mass into southeast Maine, but a little bit higher elevation in the middle of the state. But then as soon as you start going south, it is one of the most common hidalums, but hardwood associate. Spongiocepes, spongy foot. So the stem on it is just this really plush sponge that can hold so much moisture. I mean, you can literally pick it up and squeeze, water out of the stem. And so it probably helps it, grow in dry periods, just this reservoir to draw off of. These are really young specimens. They have that whitish or pallid bloom when young. As soon as it gets older, it becomes brown. When it's wet, like these are, they're really dark brown. When they're dry, they can be light brown to gray brown. So, quite variable, but that spongy stem, the dry velvety cap, well, not dry, but velvety cap, and just that spongy foot under hardwoods. Another hardwood associate is the Scrobiculatum group. I don't know how many species are in this group. It's a lot, 4 or 5 at least. It's difficult, and there's no real features I can tell you to tell them apart. But I guess just recognizing the group for now will have to do. And so they can get the red droplets when young, or pools of red on the cap. The cap it's tougher texture than a lot of hidalum, so it's woody or corky almost. And then when the caps are young, it won't have all these little growths. The scrobiculate are these these little tufts or upturned scales coming out of the cap. Scrobiculatum typically does that to the extreme, where it has all these little pilei coming up out of the center of the cap. And yeah, like I mentioned, it's going to have to take genetics to tell these apart, at least in the beginning, until we can get a sense of what actually looks like what. Scrobiculatum is a European name, and it's not known for North America currently. So there's that. But just another example. This is one that I think I can fairly easily tell it apart from this one, because it's a little bit more white and brown colored. Versus the tan and orange brown, and the flesh is a bit darker on it. But whether or not that actually holds up, I don't know. But yeah, I mean, just recognize Scrobiculatum group as a group, really common with hardwoods. It's another hardwood associate, and then fairly close to this group. That's Hidalum concrescens, which we used to call zonatum. At least 3 species in this group currently. It appears all need new names. But this is a little bit thinner flesh, also dry in the cap, but it doesn't get the large projections coming out of it. Be slightly roughened, and then it's almost always distinctly zonate. So light and dark zones around the cap. And this particular group, the concrescens group, is always with conifers. So if it's brown colors with hardwoods, Scrobiculatum group, brown colors, a little bit thinner flesh and zoned with conifers, look at the concrescens group. And another example of one. So as it gets old, they can become quite thin and wavy margin. And you can see even these where it doesn't have the growing margin and stuff, you can still see the zones on the cap. There's a small species that grows at least under northern conifers. I've never seen it in New England. I've seen it in Upper Peninsula, Michigan, and then at least there's something really similar on the West Coast with two-needle pines. A species described from Nova Scotia is the Signellum subzonatum. And so this is a really thin flesh, really small species. You know, it's only about an inch and a half across or so. It looks almost like a Cultricia when you first find it, or a Telephora until you flip it over and notice the spines. But it seems, at least where I've seen it, you know, these licheny, mossy, heathy areas and sandy soil under pine. Like I said, you know, it's fairly common, like in the Oregon coast in their coastal dunes. I have not seen this in the Northeast, but described from Nova Scotia, so it's probably there. Moving on to another group. So this is one that we used to, if we put a name on it, was sometimes called it, you know, Sarcodon piperetum, but you know, it's a hidnellum. This is a really common hardwood forest species, and I'm sure you've seen a lot of it if you know, especially in the New York area or south. And it's one that, for a common mushroom, rarely gets a name put on it. And so it's fairly easy to recognize, kind of like these gray to buff to light brown colors, these, you know, chunky fruit bodies of irregular lobe-like caps from a central stem, or typically central stem, and kind of like, you know, the dark flesh in the stem, a little bit more pallid in the cap. The cap is smooth, if not fuzzy, and it has a really peppery taste to it. So it's something that keep an eye out for. You can start recognizing this thing and put a name on it, because like I said, it is fairly common, but I rarely see it on species list anyway. There's a similar thing that's growing up north with spruce, and that's Hidnellum stereosarcinon. It used to be Sarcodon stereosarcinon. This is similar, a little bit thinner flesh than the previous one, and a little bit more orange colors, but just, you know, the spruce habitat and versus hardwoods is the previous one, you know, hardwood forest. The spruce habitat and orange colors will separate this one for you. And then the fuzzy capped hidnellums, cristatum. I think it's probably an oak beech associate. I'm not sure. I've always found it in mixed forests. It's not all that common. It's kind of like that olivaceous brown, fuzzy cap, really short, stout stature. Not all that common. I looked at INAT the other day. There's only a couple. That's the problem. INAT and hidnellums. There's a lot of misidentifications, but there's only a couple observations of this species that were actually legit. But it's something that, you know, it's distinctive with that, you know, that yellowish olive brown fuzzy cap to it. You know, keep an eye out for that one. If you're in the conifer zone and up north, anyway, look for mirabile. Red listed species in Europe. It does occur across North America. You know, I've got collections from Pacific Northwest, Alaska, and seen it in Newfoundland, but you know, it's around, but not common at all. It occurs down, you know, through the Rocky Mountains. So pretty much wherever you're in that northern conifer zone with spruce, you can probably find this mushroom. And so that are features, like, you know, this one gets a little brown droplets. It's a little bit browner in color, when cristatum's a little bit more olive, and mirabile seems to have longer stems, but that could just be based on the habitat it's growing, because it's usually growing these mossy spruce forests versus you know, these shallow duff, hemlock, beech, oak forest. Okay, so what do you do when you find a mushroom and you want to put a name on it? You can't put a name on it. You don't look at this group of hidnellum. It's frustrating. You can see, like, to the one in the bottom right was the one that I showed you. This, you know, in the beginning with the different colors to it. I've been finding this mushroom here in the bottom left for years. It goes right next to my house. It's a nice patch. It comes up pretty much every single year, but it doesn't really fit anything. And so there's a few names for orange hidden elm. There's a lot of like described varieties or Aurantiacum varieties. It's going to take quite a bit of work to sort this out because are we looking at a single species for these three, or are they different? I don't know. I mean, I can assume that they're different. And that's kind of what I've done, but the spore difference on them is not really enough to tell them apart. And then how do you know without genetics anyway, if it's all within a variation of a species? So the one that you can fairly easily recognize, hidden elm Aurantiacum, at least what we call Aurantiacum in North America, is the orange cap thing, typically with spruce, but not restricted to spruce. And then it has that bumpy roughened cap, and it has white spines, at least the spine tips. So they're white when young. They become a little bit more grayish or brown when it gets older. But the growing margin is always going to have those white spines. And there's this one, which I think is Chrysostom, but I'm not sure. It has more of the spine color is a little bit paler. It's a hardwood associate, possibly with hemlock. I mean, the problem with a lot of these hidden elms is they're almost always in these mixed forests, and so it's sometimes difficult to pinpoint what they're growing with. And then this one I think is Earlium, but I'm not sure. So this is a species described from Florida, and I think it's our coastal pine forest species, occurring up into at least up to Cape Cod, New Jersey pine barrens, coastal, the kind of those coastal pines in the southeast. At least I think that's what this one is. And so the spores on these two they're a little bit larger than hidden elm Aurantiacum, but not much, like 4 to 5 versus 3 to 4. And then they both have the orange spines. But then this thing here, I don't know where this fits in here. It's something else in this group. And so this is a group that desperately needs work. So if you want to work in that group, go for it. You can. The problem with it, I mean, it's not that you can just like run out there and describe new species, because there's so many old names. Holland Stuntz described 3 species for that group in the Pacific Northwest for these orange hidden elms, and trying to figure out what they've described is difficult. Okay, so an easy one, just based on odor alone, you can ID this one, that hidden elm Slaviolens, the really nice sweetgrass odor. Genetics shows us we have 2 different species. Stay tuned. It does that for everything, though, doesn't it? But the pale cap, which will start off white to gray, but then you can see it can go dark gray to almost brown. But then it has a blue stem, and then this zone white and blue flesh to it. And so even if it's an old specimen, you can cut it in half, blue stem, and then those zones through the cap. Some people say it smells like oatmeal cookies. And if people, the sweetgrass, really sweet, spicy odor to it. Pleasant at first, but then it gets like strong and overpowering. So you just want to get away from it eventually. So another blue one, Ceruleum is this blue one with conifers that has a fuzzy cap to it. And then the blue flesh zonate in the cap and orange flesh in the stem. And so when it starts off young, it'll be like these beautiful sky blue or baby blue colors. But then as it gets older, like that blue fades to white, and then to tan, and then to brown, and this dark brown. And so you'll lose all the blue tones from the cap, but retain them in the flesh. Same thing with the spines. They start off blue and then eventually go brown. So if you have that flesh color, you can identify it from that. Now there's another one that grows with hardwoods, that blue cap, and a lot of authors had synonymized this with Ceruleum, and it is a different species. I personally have not seen it. I've not seen it fresh anyway. I've seen some really old ones in Michigan with oaks there, but it's a hardwood associate. Besides the habitat difference, it doesn't get the fuzzy cap that Ceruleum gets. So if you're unsure of what the habitat it came from, just the Ceruleum gets that fuzziness to the cap that Ferruginous does not get. So even though it's in similar, blue colors, same flesh color, blue in the upper part, and orange in the stem. And so yeah, and this is one that it's one of the few species I've yet to find. So at least find good specimens of. So hopefully I'll come across this thing. More common in like Midwest, down to Southern Appalachians. I've not seen it in, not at least seen records that I would accept from the Northeast for that species. But once again, everybody's calling it ceruleum, so it's tough to tell. This is a really rare one. I've only seen this once. There's only a few records of it. So I think the Scleropodium, which was the name that I think of Coker described from the southeast, and then Crudentum was Harrison's name from Nova Scotia. And it's probably going to end up being the same species, but quite rare. So if you see anything like this, let me know. It has a brown, like roughened cap, bluish gray spines, a little bit of blue in the flesh color. But yeah, it's quite unusual. The only modern records from down south now are like Great Smoky Mountains National Park and these remaining stands of old growth. So but at least the northern species, Nova Scotia, this was in Quebec. It's around, so keep an eye out for this and let me know if you see anything like that. And then another rare one, Geoglinium is a yellow spines. This is a photograph I took in a long time ago, early 2000s, on a slide that I scanned. This was from up in Newfoundland. And I just like saw this clump and did half-hearted throw it in the pile and shoot it. And I proceeded not to see this mushroom again for a lot of years. I have better shots now, but I didn't get them into the talking time. But it's unmistakable just in the fact it has bright yellow mycelia. So that mycelial mat in this thing is bright yellow and the spines are yellowish green. So that's it for Eastern Hydnellums that I'm going to touch on. I am going to move to, Eastern Hydnellums in the as we used to know Hydnellums. I'm now going to move on to the Hydnellums that used to be known as Sarcodons. And so this is probably the most common one people are going to see. And as far as I can tell, it needs a name. So it's what we call Sarcodon scabrosa, scabrosus, now Hydnellum af scabrosum. Hopefully the dog doesn't bark too long. So this is, widespread Northeast hardwood forest, possibly coniferous forest as well. I'm not sure. It may be different species. But it's, this scaly brown cap, blue stem base, and bitter taste. You're going to see it all over the place. And it's going to be in pretty much every single book as Sarcodon scabrosus, and on most websites is that as well. It is not Sarcodon scabrosus, or now Hydnellum scabrosum. This is the actual Hydnellum scabrosum, which we have it restricted to pine forests, at least from what I can tell, where I've seen it. I'm in the Northeast. Possibly it grows with spruce out west, so it's probably up north with spruce, but records get a little bit muddied because nobody's been putting the right names on these things. But scabrosum has that pinkish brown cap with the little scales, blue stem base, and extremely bitter taste. So fairly easy to identify. Just based on that shade, the pink brown shades of that cap, you can see the cap kind of like breaks up a little bit into the scales. When they start up young, they can be really pale colored on the underside, almost fool you into thinking it's a Bankera, but the blue stem base will be immediately giveaway to the species. Also in the hardwood forest, you're going to find what's now Hydnellum underwoodii, formerly Sarcodon. Really similar, except it doesn't have that blue stem base. It's actually usually a little bit larger in size, and the scales are a little bit more acute, a little bit more pointed to the scale rather than the oppressed to oppressively frex, kind of like those scales that press down and curve up, when underwoody eyes are going to be a little bit more pointed. So white stem base, white mycelium at the stem base. So that's an easy way to tell it apart. You can, I know some people have eaten this thing. It's borderline bitter. I wouldn't eat it myself, but then again, I don't really eat mushrooms. But I know some people are trying it. There's this one here in this group with the the blue stem bases. It's close to the European glaucopus, but different. As far as I can tell, it needs a name. Once again, a pine barren, 2-3 needle pine species. And then the group Sarcodonaceae varieties. So this is the group of Sarcodons. They all have these really dark colors, dark olive to olive black colors to them. Often like the round cap, central stem, kind of like act like a normal mushroom when most hydnelms and Sarcodons don't. But this particular group, this does need a new genus. So it's not going to be in Sarcodon much longer. So that this group of Sarcodons is going to move out. And I'm not sure, I don't think that all of them anyway are going to be ectomycorrhizal. There's some from South America. I know the one in New Zealand grows in spots that there's no known ECM trees. So it's probably some saprotrophic species within this group of Sarcodons. But we'll wait and see on that. And then there's, like I said, this is the most difficult group, especially when you get out west. There's no names for most of this stuff. And the names that do exist, not exactly sure what you can apply them to. So you're going to find a lot of these that just don't fit anything. So keep that in mind. Sarcodon imbricatus, the hawkswing, this is a spruce associate. And as far as I can tell, restricted to spruce. So if you're not in spruce forest, you're probably not finding imbricatus. And so this is the hawkswing. This is one that, if you're out in the Rocky Mountains, you're going to find a lot of it, or, up north, boreal forest zone. This is one that a lot of people do eat. I think it's an acquired taste, but it's often a big, meaty mushroom. So, it's easy to get a lot of it if you're in the right habitat. Really similar to Sarcodon squamosus, but this one's often darker. This is not the best example I could have used for a photograph of it because the scale pattern can be almost, identical to imbricatus. Just typically a little bit darker of those larger, scales to it, but often growing with pine. And then it was actually the mushroom dyers who noticed this was a different species in Scandinavia, where they could, this one would dye blue-green color when the imbricatus would just give a beige. So they mentioned to taxonomists that, these things are different. When they looked at them, yeah, they were in fact different. I guess I put one out of order here. This particular species, this is a rare one. I've seen a handful of times in the Northeast. It's this now hydnelm, our former Sarcodon, brownish scaly cap, but when you cut it in half, it stains that violaceous color to it. So that pinkish or violet color to the flesh is distinctive for this one. I think so. Subincarnatus is a similar species that grows with spruce, and I have not seen that species. Phelodon or Bankeraceae is the white spored group, so looks a lot like a Sarcodon, except you can see the dusting and white spores here. This particular mushroom has white spores, really sweet odor to it. They often have these sweet curry odors. Another example of this, I see it with hemlock in the east. I've seen it with 2-needle pines in the west and spruce in the north. So same thing across North America. And another one, the Phelodon or Bankeraceae, Fuligino alba. This one appears to just be a pine associate, but once again, across North America. And what's distinct about this one, really short, growing to the ground, but the cap always has that binding debris to it. So wherever you find this thing, it's always going to be, the cap is always going to be stuck with debris, even though you touch it, it feels dry. The cap, it's like this fuzzy cap tissue that binds the mycelium to it. And then the last group here, these phelodons, I really don't know what to tell you about this group except get out there and study them, because there's so many species, probably 10 or 12 different species using 4 names. So we'll give you the group names and you can go look at the difference. Melanoleucus, dark, Lucas white, so dark cap, white spines. Small species with that, the combination of the two there. This is another one in that group for the Northeast. This one grows with hemlock, this one grows with pine, maybe. There are a bunch of names available, so that makes it a little bit harder. Phelodon niger, the Northeast one is not the same as the European one. We know that. However, there's just a sequence from Washington that matched the European one, so there's more going on here. But the common Northeast hemlock thing was, this bluish to bluish black cap, the bluish gray growing margin, that really the duplexy stipe, so squishy, spongy stem. This thing's fairly common, growing with hemlock, needs a name, it appears. There's a few old names for phelodons, got to figure out what they are. It's also one of the best dye mushrooms. You get really good blue colors from it. And, like I said, fairly common. One that I wouldn't feel too bad about dyers picking a lot of. Some of these other ones I would, be hesitant to suggest that they get picked. Phelodon aboniger there's a whole taxonomic mess about this name. A lot of sites like Index Fungorum has it synonymized with niger. It is not. It's a really distinct species. Growing with hardwoods, grayish to whitish to grayish, fresh growing cap becomes that light brown, dingy brown color. The duplex stem flesh, brown cap flesh with the brown on the outside of the stem, and black core, hard core to the stem, and these white spines, those spine tips. So fairly easy to recognize. Hardwood forest one, similar, and another really great dye mushroom. Similar to Phelodon confluens, which forms these really large masses of fruit bodies. It just confluent, fuses together, and some of these mats can be a foot, 18 inches across, and doesn't have the duplex stem that aboniger has, but similar colors, different KOH reaction as well. And yeah, it's one thing I can mention. Dropping KOH on some of these things, it can help, especially with the Sarcodon or Sarcodon-like species. So I'll be sure to let Russ know before he tries to eat anything, that these things have potassium hydroxide all over them. It's a little bit caustic to eat. And then the most common one in conifer forests is Phelodon tomatosus. The owl eyes, the zone cap with the brown center and white margin. So fairly easy to identify this one just based on the brown colors. You can see brown flesh and brown centers, cap, white growing margin. So I will leave you with one of my favorites, which is a West Coast one. This one grows in coastal Sitka spruce forest, Northern California, up into Southeast Alaska, Hibernum cyanopodium, which is a blue bleeding tooth, because beautiful blue colors, flesh and spines, and when young, they can just be covered with red droplets. So it's quite the spectacular mushroom. So I hope I haven't scared too many of you off, but it is a difficult group, and it's going to take a dedicated bunch to figure it out and to be interested in it. And so with that, I'm happy to take questions. And
that was amazing. Thank you so much. I think a lot of people are intimidated by these genera, and I think a few of us are now probably going to try and take more of them to species, because it's such a beautiful, weird, fascinating group. That was just an eye-popping tour de force. Thank you.
Yeah, it's a relatively small group.
Mhm.
You know, I guess it was like a little over an hour to go over all the species in the Northeast. Well, I left out a few of the northern coniferous things, the sarcodons and stuff or sarcodons from up north, because I have not photographed everything. And I shouldn't say this out loud. I hesitate to suggest Michael Quebec for this because there's so many misidentifications and they're too fungi in that site. But they do have a few examples. I know Renee has a few photos up there of legit identified stuff that I don't have.
Right, great.
And yeah, so for a small group, it is like you said, intimidating. But there's not that many species. But I much rather, I mean, I can more confidently identify Cortinarius than I can Chenellums.
Right. Okay. Well, you made it a little bit easier for us. So we have a whole bunch of questions in the chat, and now's a good time to also add your question. And I'm going to call people up to ask their questions. So I think the first one is Penny Soppers. Would you mind asking your question for us? Penny, you can unmute yourself.
Okay, I got it. I muted myself. Thank you, Noah. That was very interesting. When you were talking about convergent evolution, I was wondering what is the advantage of spines that so many lineages would evolve spines?
Surface area. I mean, it's the answer to everything. So, you know, imagine a flat mushroom. You know, if it's a 4-inch cap, it has a 4-inch circle of surface area. Now, if you add tubes or spines or gills to that, you can start covering a lot of ground. And so the example I use in one of my talks is that during one of the Santa Cruz fungus fairs in the drought years, this is in California, it was painful because it was, you know, I was sitting at the ID table for 3 days and no mushrooms are coming in. Someone finally brought in this large Gymnopolis ventricosus, which is the jumbo gym, and you know, it's a mushroom cap about a foot across. And I proceeded to cut all the gills off of this cap and start laying them out on the table. And it covered pretty much a whole entire table with gills. So the spore producing surface area of that mushroom, it's not just one table, it's 2 tables because it's producing on both sides of the gill from a single cap. And so if you were to do that with the spines as well, you know, pick up every single spine, it would cover, you know, a surface area that is probably, you know, 10 times greater than your little circle, depending on the length of the spine. So just, you know, these additional structures, whether it be pores, gills, or spines on undersides of caps, it just increased surface area, which is increased spore production.
Great, thank you.
Okay, do the spines have more surface area than pores?
It's about the same. So on a pore, you know, just picture a straw where the spores are produced inside the straw. So say it's like 5 millimeters long and a 0.5 millimeter thick. And so on a spine, 5 millimeters long and a 0.5 millimeter thick, the spores are being produced on the outside wall of the spine. So it's about the same surface area as a pore. It's just on the outside of the spine versus the inside of a pore, you know, tube.
Okay, thank you so much. The next question is from David Andrew White. David, would you mind asking your question? All right, I'm not hearing you, so I'm going to ask it for you. Is the family name to be changed, i.e. not Bankeraceae? I think that's in reference to Bankera having a name change. Does that impact the name of the group?
No, it did because of yeah, I don't believe so, because if it's described from a family level, it's not affecting the genus level, even if the genus is then being subsumed into Phelodon, which was the older name in a different family, but it's the oldest name for the family.
Right.
Because I mean, before, I mean, there were, you know, all the spine fungi were lumped together. And then there was there's a mix up with hydnum and dentinum, because what we now know as hydnum, we're considered dentinum, which is in the Hydnaceae. So chanterelles are like in the hydnum family. And then what we used to call Sarcodons hydnum. So it used to be hydnum imbricatum. So yeah, there's taxonomic and mix-ups, and then nomenclatural mix-ups as well with this group.
Right, sounds like it. All right, Ming, you're next. Ask your question.
Hi, my question is actually rather simple. You mentioned actually a lot of different species, trees are associated with the growth of these tooth fungi. So are all these tooth fungi mycorrhizal?
Yeah, it appears that almost all of Bankeraceae are mycorrhizal. I think the Telephoraceae, right? I mean, except for possibly the small group of the Atrovirtes group of Sarcodons, which at least the New Zealand species I have questions about, and then there's a couple from South America that were in spots that may or may not have mycorrhizal species there. It's really easy for some of these coccolobos to hide in tropical rainforests and not notice them. But then I know that the Sami dominated forest that I was in Guyana had a Sarcodon in this group described from it. But I am not positive. I know the stuff I found in New Zealand had no ECM stuff. It was literally in the ECM gap. So pretty much, without much hesitation, I can say that everything in North America is ECM, with the only exception possibly is the Atrovirtes group.
Sure.
So it is important to know what tree it's grown with.
Okay, thank you very much.
Okay, great. I think the next question is from Laurie. Laurie, you had a very specific question about distribution.
Crap. Hi, can you hear my mic?
We can hear you.
Okay, good. I wasn't sure because it was unplugged, so we had to scramble to do that. And I'm sorry, I joined late and I don't remember which hidden alum I was looking at when I asked that question.
Ferrugiapes, I think.
Excuse me?
Hidden alum Ferrugiapes, I think you were asking.
Oh, yes, that's right. Yes. So actually, I'm in North Carolina. Hi, Noah. You were here a number of years ago.
Yeah.
I met you then. And I was wondering if that occurs in North Carolina. Are you aware of that?
Yes, it does occur in North Carolina. And ceruleum is not known from North Carolina.
Okay.
And so the best thing I will mention, I forgot to stick them in there. The two of the resources you should use for the stipitite hydnoid fungi of temperate southeastern U.S., which is Richard Byrd.
Yes, yes,
that is probably the best resource for East Coast stipitite hydnums right now. And there's the title for that. I mean, that covers all the stuff known from the Southeast, and it's going to show you a bunch of these, these phelodons that have names that we should probably be looking closer at.
Okay, thank you.
All right. I think Luke Smithson, you had a similar question.
I did, thanks. That was a really good review, Noah. Thank you very much. It's really great. My question was exactly that, about references. Maybe you could repeat the name of the book that you just mentioned.
Oh yeah, I sent it to a single person in chat.
Okay. Yeah, but that was my question. References that we can follow up this talk with.
Okay, I just put two in the chat. One was with all the splits on hidden alum recently. Another one was the stipitite hydnums for the Southeast. Yeah, Ken Harrison's book, Stipitite Hydnums in Nova Scotia, is really good. I have a PDF of that. It's really hard to get print copies of that. So feel free to email me for a PDF. And I'll put that in the chat as well. So grab this if you don't have my email.
Thank you. That's very
awesome.
kind.
Thank you very much.
All right. And Mike Inskeep, you had a question.
You take great photos, and I was wondering if you have any photography tips for us.
Patience. So, set up the shot, like when I find the mushroom, I look around for more. If you stop and look, you will find more. That's like, it takes about a half an hour to get a shot. In terms of equipment, I don't really care what camera I'm using. I intentionally, until this year when it finally broke, I was using a Nikon D90. I had the fancier Nikon bodies and I always went back to it. And the old 60mm macro lens, it's just, and everything's shot on a tripod. In terms of my setups, you can see that they all follow the same, the same general shape. And there's a reason for that, because you don't exactly notice it when you're looking at the photo, but pretty much everything, the way it's set up in the photo is about the same plane, just the angles I use. So there's not one thing, really far back and really far forward. So you can have, a depth of field that gets everything in focus. And then, it's just like, I don't mind laying on the ground for long periods of time in the rain to get the photos. And so that's something that you have to do to I don't know, you don't have to, but it's helpful if you do.
Great, thank you. Charmaine, you had a question.
Yeah, thanks. It seems like tooth mushrooms more commonly have guttation, that liquid, than other kinds of mushrooms. Is that so? And is this liquid necessarily the same color as the spores? Thanks.
The liquid color has no bearing on spore color at all. And there's been some articles written on why they're doing it. Has anybody actually proven why they're doing it, or is it all theories or not? Somebody else has to answer that. I do not know exactly why tooth fungi are doing it. And I would challenge anybody who say they know for sure too.
All right. Great. Marty, you had a question.
Hi, Noah. I know you know Laurel Lake in Irving. What are those beautiful blue hidden elms I see in the fall there?
At Laurel Lake, I think it's all Felodon Niger. And so that, that can be quite blue colored when young. So
Yeah.
that at least that's the one I've seen there.
Thank you.
Great. All right. Greg Marley, you had a question.
Yes, thank you. Noah, incredible talk, lots of density, lots to chew on. I have struggled for years, but differentiating between hidden elm mirabile and hidden elm cristatum up in Maine, primarily in mixed hardwood forests. Can I show you just a couple of quick photographs and ask your opinion?
Yes, Siegel, can you allow screen share for participants or not?
I think it's enabled. Yeah,
Okay.
Here we go.
So here's one.
Yeah.
And here up, let me see if I can get here's the cross section of it. But it's got that a little bit of that yellowish color to it.
Yeah.
And I would
lean towards cristatum in that one.
All right, and then the next one is very deeply hirsute with more of a brown tooth, but none of that yellowing.
Yeah, that's a little bit more on the mirabile side, but I don't know. I mean, I have some question if they're in fact different.
Yeah, and I do too, after I've seen him for years. So that's why I ask, yeah.
Besides habitat, I mean, so mirabile and cristatum, it seemed, I mean, habitat's fairly easy to tell them apart. I'm not sure if I have easy access to additional photos. you know, they're really similar. Let's try to. So here's another Mirabile shot.
Yeah.
Mirabile seems to be larger and more complex than Cristatum. Cristatum tends to, you know, a little bit smaller, stouter, and single caps. And then, you know, more yellow to olive tones versus the dark brown. So your second photo, I would say a little bit more like Mirabile. Your first one was a little bit more like Cristatum.
Yeah. Okay. Well, thank you very much. Very helpful.
Great. All right. I think we are all out of questions. Thank you so much for patiently answering. You know, this was a stunning talk, especially in the middle of February when it's cold and, you know, we all can't wait for the season to start again. So thank you. That was great. Really appreciate it. And I know a lot of people in chat said the same thing.
Can I just say, no, it was fabulous. You confirmed a lot of what I think I still know and talked about a lot of things that I've observed, but also that I didn't know. So this is an awfully fun group to really look at. So I would encourage people, pick them up, turn them over, look at them, and they can look very different between when they're wet and when they're dry. So sometimes if you cut them in half and they're wet, wait a couple of days before you look at the interior and see if it changes a little bit in the flesh. Anyway, thank you. No, it was fabulous. I'm going to email you separately for other questions.
That's great advice. Thank you for sharing. Yes.
Yeah,
All right.
thank you, Susan, for starting me down this path of tooth fungi, because you know, it was a group that Susan was the only person who was looking at them at these forays, and you know, there'd be people slapping names on them. You just like shake your head. It's like, no, that's not it. And I remember Susan like porch full of different species of some of these, you know, forays, like looking at them and showing me differences. And then, you know, it's just something that I was like, you know, got to figure out what's going on here. And I must say, it's nice to see a lot of these people that I haven't seen in over 2 years. And hopefully I'll see some of you in person this coming year, you know, now that things are a little bit more back to normal.
It would be great to have you over on the East Coast, maybe see you at some of the forays.
I'm on the East Coast more than I let on, especially the last 2 years, but so I'm around.
All right, great. Okay, wonderful. Thank you all for coming out this evening, and thank you, Noah, again for answering all of your questions. So very much appreciated. You all have a great weekend and see you all soon for the next talk. Okay. Good night, everybody.
Good night, everyone.
Bye.